So now how can we price a swaption, right? Well, if I have a one factor model, we can try to borrow the approach that we had on pricing options on coupon bonds to price swaptions. Okay, so recall that a swaption, in this case, say for example, option on a pay fixed swap, really is something that what allows you to enter into a swap, which you will have a payoff structure like this. Okay, just some review stuff, and take a look at the those slides related to swaption. And basically, you have a swaption here with a swap, underlying swap that will start here. Okay. Now, how are we gonna price a swaption and to reach a closed form? Well, in this case, to not just price it, to get a closed form solution for a swaption. Well, we can view a swaption as an option on coupon bearing bonds. How are we going to do that? So you can basically turn swaps into coupon bonds. The way to do that is you swap basically have two legs, the floating one and the fixed one. So and the swap really, if you add up the difference between a swap and a coupon bond is that the coupon bond has the final face value payment, whereas a swap doesn't have it. But then let's say you add $1 to both legs on on the final date of the swap exchange. So in this case, you add, so the floating side has to pay an additional $1 to the fixed side, and the fixed side has to pay additional $1 to the floating side. They cancel out, so the value of the swap doesn't really change, right? But if you were to do that and you break the floating side and the fixed side apart, you actually have constructed two coupon bonds. One is the fixed rate, the coupon payment is fixed. The other one, the coupon payment is floating, right? So you actually created two coupon bonds. Now, once you have done that, and suppose the discount rate you use is really the floating rate that you used in the floating coupon bonds, then what you basically have constructed is that you have the floating leg, will then be the strike price K. So because it's discounted at the floating rate, the floating side will always have a fixed value, which is actually the notional of the swap. But the fixed side would not have the value of the fixed side is not the notional, and the value of the fixed side, you can treat it as a coupon bond in this case, and the coupon rate would just be the fixed swap rate. Okay, and the face value is really then the swap notional. So once you have done that, you basically you're exchanging your swap, exchanging one side for the other. So if it's in this case, we have a let's say we have a pay fixed swap, then you will pay essentially you will be a put on the coupon bond, because the put on the coupon bond is you would the value is K minus the value of the fixed side. So which means you are receiving your pay fixed if a swaption on a pay-fixed swap, the swap really allows you to receive the floating side and pay fixed. The floating side has a value of K, and the fixed side has the value of the coupon bond. And you now have an option of a coupon bond where you have a strike which is equal to K, and the other value, the floating value, would just be the value of the coupon bond itself. So your swaption, to enter into a pay fixed swap, would now be a put on a coupon bond B, okay? And vice versa. So you will have a swaption enters a receive fixed swap. You then have a call on a coupon bond B, okay? Again, the strike price is over the notional of the swap. Okay, so basically now you have turned the question of pricing a swaption into a problem of pricing options on coupon bonds. And because if you have a single factor process, you have a closed form solution for options on coupon bonds. You now have a closed form solution on the for pricing swaptions. Okay, again, this is only valid for models where there's one single factor. Okay, although this approach is not just valid for Vasselchak, it's valid for every other single factor models. So so if it's not just Vasselchak, as long as you have the closed form solution for options for the options on zero coupon bonds, you can use the approach that was presented earlier to turn that into a closed form solution for of options on coupon bond, and also a closed form solution of swaptions where options to enter into swaps as well. But you really cannot do that for multi-factor models. And for multi-factor models, you will have to go into using numerical approach.